Okay, so let's start by taking a question from the audience. How do you know when it's grounded enough? And how can you actually verify the grounding?
So for me, grounded means it's not hallucination. So I verify that there is no any additional information in the answer cannot that didn't appear in the context that we have. And I used LLM to do this. You can also use maybe more straightforward checks of different words that you want to check that they do not appear in the text or specific versions of sentences. But in this case, this is what I used.
So I'm going to just say that some of the stuff that we use in order to verify that things are grounded, and there is an underlying assumption in what I'm about to say, because when you're retrieving stuff with RAG, you hope that you're retrieving the right material. And that's kind of a more difficult question. Like, how do you actually retrieve the right material? And to that, I'll answer there's a lot of work that goes into it, mostly in the chunking and the retrieving strategies, and you have to test it. And then when you're actually doing the retrieving, I very much like two ways of validating whether we are using the material that we fetched. It's not necessarily, as I said, the right material, but assuming it is the right material, you can use two metrics or two strategies in order to gauge this. The first is using an LLM as a judge, what's called the judge LLM. And the other is the faithfulness, which is a metric, and it's easily accessible through RAGAS, which is a framework for measuring and evaluating RAG performance. And essentially, faithfulness allows you to validate that you are using the information retrieved in the RAG in order to answer the question. So it checks the key concepts between the two and how many of those are used in the answer and how many are just new to the concept. That would be my answer. Let's jump to another question. We're all very much familiar with the tech stack progression, and both me and you, when we consult companies or work with companies, emphasize the need to start from prompt engineering and gradually move on to RAG, maybe fine tuning, and eventually agents. Now, we don't see a lot of agents in production right now.
Mm-hmm.
And I'd like to ask you why you think that is the case.
Mm-hmm. So maybe it's not yet. We still, I'd say, lack of established best practices because the field is still young and there is no any clear formula or a cookbook to how to design and deploy agents effectively nowadays. So this would be my first answer. But also, if you want to put a lot of AI models together or tools together and you want an AI to orchestrate all of this together, it gets complex. And once it gets complex, the error might propagate between different components, and it will be very hard to trace it. And the goal of the original task is hard to maintain along the way. Also by means of cost and time. So for different tasks that you want to do, you want it to be real time. An agent running behind the scenes, it might take it a lot of time to run. And also the costs of using the text as input and output, a lot of tokens for an LLM on a very large scale, that can be very expensive for companies.
There's a very good question here from the audience again, which I want us to kind of address because it comes up a lot. It looks like a lot of the time to get an answer is huge, Also looks like it consumes a lot of tokens. Maybe RAG is not suitable for this. How about fine-tune model in the book? So basically, I think he's stating two things here. He says that right now it takes a lot of time and a lot of tokens. And maybe instead of using RAG, perhaps an approach on fine-tuning on the book is more suitable.
It could be a solution, but also if you have if you have your own data and you want to change the data sources, like in most cases, the data is changing. And if you want to talk to your own data, you have to update it on a regular basis. And it's not feasible to fine-tune your model every second day. So in my opinion, and also the costs in this case are not that high. So the chunks are not that big, and you distill it and it runs in a plausible time. So I don't think that there is only one solution for solving any kind of problem, but in this case, I find the reg solution more to fit more the problem.
I'll give my perspective on this. First of all, I think cost and time are valid points. And this is just the nature of things right now. Even if you're not using agents, but definitely when you're using agents, the repetitive nature and the multiple calls do add up in terms of cost and time. I would try to refrain from jumping to fine tuning. Yes, it can work, but it's not as simple as other techniques and not as simple as RAG. And the one big caveat of fine tuning is that it's very, very sticky. If you fine tune to a specific model, you're now using that model until you want to switch, and then you have to repeat the process. More I'll say is that data is changing, and continually retraining and fine tuning the model is harder than simply updating your vector database. And if I had to think about what I would recommend or where I would focus had we been doing this project, I would probably focus a lot on the chunking. And before fine tuning the actual model, I might fine tune the embedding model that I'm using in order to insert things into the database. And obviously, it affects the way I retrieve. That way, I would have a very efficient way to retrieve less data much quicker, and it would help on both ends. It would be faster and it would be cheaper because I'd be fetching more relevant data, but I'd be fetching less of it. What model did you use in the actual demo?
So I have a lot of trial and error in the project that I did. I tried to save money when I could. So for some tasks, I used the GPT 3.5. For some tasks, I used the GPT 4.0. And for some tasks, I used Llama 3, 70 billion parameters, which I could use through Grok, which gave some no cost use for this time. So I was also trying to have the sense of the which model, how does each model perform in my case. It, as you could see, the graph contains a lot of edges, a lot of vertices. Each contains a function, and the function contains an LLM. So I had to use a lot of different experiments along the way.
Yeah, experimentation is so crucial, and evaluation and benchmarking are so crucial, and the methodologies around it are definitely still evolving. And I will add my 2 cents here, and it's not something that directly answers the question, but I think it adds value. If you're looking for a quick and easy win and you are kind of faced with the questions of which model to use, and assuming you don't just want to use the cheaper one for cost reasons, or you're not just willing to use the most expensive one, GPT 4.0, You can go towards strategies such as like waterfall. And we do utilize a lot of the times waterfall strategies when, let's say, for example, we have a classification problem. Yes, GPT-4o is great at doing classifications, but so are some of the older transformer models. Specifically, there are a lot of BERT classifiers, and we can get away both in terms of cost and in terms of latency with using those. But if they're not good enough, we kind of create this waterfall where we'll first try like the cheaper, faster one. That's not good enough. We'll move forward and so on and so forth. And better than just implementing this on your own, recently MSys released Route LLM, which is an implementation of based on an implementation of a paper called Frugal GPT by Stanford. And it sounds what the name implies that it does. Sorry, it does what the name implies. It on the fly decides which is the best model to try and answer that question. And that can help you, again, save cost and time. And also in implementation, it will probably be much faster than writing logic around how you want to do that said waterfall that I explained. Great. Let's talk again about the project. So both in the context of the project and agents in general, what do you think are some improvements that are much needed? I mean, yes, there's a lot of hype in agents, but we have to be honest and say that most of these frameworks are, younger than half a year. Even LangGraph, which is one of the, I would say, top three established together with Crew AI and AutoGPT, hasn't existed for more than a couple of months. So what are some improvements that you'd probably work up in the near future in the project? And what are some general improvements that you think could be applied to the framework or agents in general?
So I guess it's totally different questions, because in my project, I know that there are a lot of components that I would improve, not necessarily in the agent side, also in the agent side, but not only. So I think in every step of my project, I could have improved it. For example, from the embedding phase, the chunking, the embedding, the prompt optimization in each function, and there are a lot of them. I would also think in the agent side, well, look, this is a proposed solution. I could have thought of a much more complex or different types of tools that I would like to have. And maybe if I'll test different questions, I'll figure out different needs that I didn't cover. So I guess that a trial and error using a lot of different questions, I can use this to understand where are the weak sides of this solution and suggest maybe different components. This, for example, how I realized that I would like to insert in additional vector store of the quotes. I was playing with this with my brother, and then he asked me the question about Hermione, and then I said, oh, I don't have this kind of resolution to answer such questions, so I need this to add additional kind of access to our information. And for the other part of your question regarding agents in general, well, I think that I tackled some of the weaknesses of agents nowadays in my project. So the weaknesses are maybe the planning and the reasoning capabilities that the agents need. Maybe also, and of course, to be able to check that the information that it takes along the way is grounded and does not produce hallucinations. And
Yeah, that sounds.
Another thing is, like, I think we want to have a more seamless integration with external tools and APIs that is not
Definitely.
supported today.
Definitely. Yeah, I'm just gonna focus on one because all of the things you said are definitely correct. I'm a big advocate of, the way Jan LeCun sees things from Facebook, and he really focuses on better planning capabilities and
Mhm.
advocates that it should be, a focus in and of its own and not just a byproduct of working with agents. And I wholly agree with that. Let's jump on to the next good question here. Um, Basically, a guy asked if an agent can get into with another agent, and obviously this would apply to like a multi agent system. And I was
Mhm.
wondering if you have any thoughts on that matter and maybe how to curb it, and maybe using a different technology.
So the answer is obviously yes. I encountered in this many times in this project, for example, where the agent is using another some tool over and over and over again, and a tool could be represented by an additional agent. So the answer is yes. How to prevent it? So I prevented it. You can tackle this with different ways. You can have some memory that knows what was your last step and or which was your last tool that you used, and you can verify that you're not going to do the same action again just by observing what was the previous action and what's the action that you're going to make. So this is a solution that I made in this case. Do you have your own perspective over this?
Yeah, so first of all, memory can help because you're dragging it along, and the bot can kind of see that it's potentially see that it's kind of looping in and of itself. It's not a fail-safe method, but sometimes it works. Second, you can simply limit the number of requests. Both the libraries allowed to do it and some very well-known solutions such as GPT Researcher allowed to limit
Mhm.
the number of calls that it can make to prevent loops because they are an issue. A better stopping condition is another way, and using other tools for external verification as a stop check in certain nodes can
Mhm.
also be very, very beneficial. And I want to stress that a bit. There's this notion where Gen AI in general is now this new capsule where we try to solve everything using it. And that is definitely not the reality. In reality, it's a combination. It's a combination of Gen AI together with existing APIs. It's a combination of external validation metrics in a Gen AI pipeline. Not every validation has to be done with an LLM. Yes, Judge LLM is a great way, but sometimes having an external taxonomy and just checking that it maps correctly to that is a very valid way, very cost efficient way. Um, and I want to stress that we're not migrating to this entirely new stack. We're slowly shifting, and it's a combination of the two for the very long foreseeable future. Great. We do a lot of RAG, and when we're doing RAG, we're concerned about retrieving, which is why we employ things such as re-ranking and spend a lot of time focusing on chunking. And do agents, and this is kind of intentionally phrased this way, do agents make things obsolete? Are we not going to be doing prompt engineering in RAG in the near future and only be writing agents? Is flow engineering the answer to all our problems is what I'm trying to ask.
Well, I'm not a prophet. I can give you my own perspective over this. Look, I think that efficient retrieval is still crucial for agent performance. Because the agent is using what it gets from the retrieved data. So you do want to put some effort and emphasis on this step because you could look at it at some kind of pre-processing your data, right? So I do still think that the chunking and the re-ranking and everything they do in this phase is important. Saying this, I would say that agents can make retrieval more dynamic and context aware, and they can retrieve information over multiple steps if they need to. So this makes it a little bit easier.
Great. That's
Well, also you can, it may reduce the need for a perfect initial retrieval because the agent can refine it and can iterate on the searches. But still, I'm going to the first point that it is important to put the emphasis on the chunking phase.
I want to paraphrase bigger, stronger, better. There's potentially this notion that, you know, agents are great and they are, and they're going to mature and they're going to get there eventually. And they do have some valid use cases right now. I don't want to make it sound like there's no reason to use agent. Not at all. There's some very good use cases for agents, such as text to SQL and many others. Let me throw this at you. Agents are great. Therefore, more agents are better. What are your thoughts?
More is also more complicated, you know, and when it's more complicated to track it, to debug it. You may have more hallucinations inside, and everything is getting in scale. Not always the scale is better, and not always a lot of agents is better. I think that if you can construct your own solution on a smart way that fewer agents can solve the specific tasks, it might be better than just, you know, putting a lot of agents together and think that the more is the merrier. Not in this case, I would think.
Yeah, my perspective is it's good and bad, and definitely not a first step. I'll explain. Yes, there is value in decoupling things, and agents are hard enough to debug, and they're definitely hard to debug if you're giving this one agent a lot of tasks to perform. And now it has to, in essence, generalize over these varied tasks. So decoupling them makes things easier in certain terms, because this agent that does this task, the other one does the other, and maybe we have this kind of a parent agent which plans and executes the different tasks to all of them. But on the other hand, you're multiplying the complexity of the system the more agents you have. And if the first agent, let's say, had 90% accuracy, and the second also has 90% accuracy, both of them together in a serial manner already have 80%. And this gets worse, obviously, the more agents you add. And you have to remember that these methods are never 100%. So it's not like you're going to close this agent and this one is 100 and then the other one is 90. And now you got to just bump that 10% up. Not at all. They're always going to have a margin of error. They're always going to hallucinate. There are always going to be problems. This is just the nature of the beast as it stands today.
Yeah.
And you're going to have to employ other strategies and methods to kind of curb this propagating, multiplying error and stuff. Great, guys. I want to thank you all very much for joining. Neil, I want to thank you for giving us this wonderful session.
Thank you.
As always, if you like the session, let other people know. Please like, share, and subscribe. And we'll see you again next time.